Whenever we're working with chemical reactions, we're going to use chemical equations which involve proportional reasoning. So if we take something like phosphorus and react that with chlorine gas to form phosphorus trichloride, we imagine that the phosphorus is made up of P4 molecules, the chlorine made up of chlorine molecules, and the phosphorus trichloride PCl3 molecules. And you can write down something called a balanced chemical equation. Now this equation can be interpreted at the molecular level or at the observable level. So I want to show you how proportional reasoning enables us to go from the molecular level through to the observable level to answer a typical question like this one. What amount of chlorine is required to produce 1.2 moles of PCl3? Okay, so let's start off with the equation, notice written without the states, because we'll interpret this at the molecular level. This says that 1 molecule of phosphorus, P4, will react with 6 molecules of chlorine to give us 4 molecules of PCl3. We can multiply throughout by 10. We could say 10 molecules of PCl4 will react with 60 molecules of chlorine and to give us 40 molecules of PCl3. That's just proportional reasoning, yeah? Now if we were to multiply, instead of by multiplying throughout by 10, we multiply throughout by 6.02 by 10 to the 23rd. So 6.02 by 10 to the 23rd molecules would react with 6 times 6.02 by 10 to the 23rd molecules to give 4 by 6.02 by 10 to the 23rd molecules. That's a ridiculously large number, and the reason that I've multiplied throughout by that number is that that is the number that we associate with the mole. So 6.02 by 10 to the 23rd formula units of a substance is called a mole. So that many molecules of phosphorus is 1 mole of phosphorus. And 6 times that would be 6 moles of chlorine. And this is 4 moles of PCl3. So what we've done is scaled up from the molecular level up to the observable level in which we're working with substances in the laboratory. Now this equation is really useful and we can answer questions like the one up here. What we need to do is to work out how much chlorine we need to produce not 4 moles of PCl3 but 1.2 moles of PCl3. So what we do is we set up what we call the stoichiometric factor, where we say the number of moles of chlorine divided by the number of moles of PCl3 is 6 to 4. So the number of moles of chlorine to the number of moles of PCl3 will be 6 over 4. So therefore we can write the number of moles of chlorine will always be 6 divided by 4, and we'll bring that term up to the top here and say that's multiplied by the number of moles of PCl3. So now, if we want to produce 1.2 moles PCl3, we put in 1.2 moles in here, so that'll be 6 over 4 times 1.2 moles. That gives us 1.8 moles of chlorine required. So the idea of this example was to show you how we can take an equation at the molecular level and scale it up through proportion up to the observable level involving moles. So now 1 mole of that will react with 6 moles of that to form 4 moles of that. And then we can set up this thing called a stoichiometric factor, which enables us then to calculate quantities that we want from questions.